installation is designed to be safe, fast, and straightforward. In the next few minutes, you'll see the key steps in the process. Accurate measurements are taken for the equipment positioning and cable lengths. To improve accuracy, it is recommended to use 2 points of reference, such as Omnicom video measurement as well as site physical measurements. The rail is marked at the measured-in position. The site is also tagged with the equipment ID and barcoded. The barcoding will be used later in the process. The briefing contains the normal safety information such as hazards, access arrangements, and protection arrangements. It also includes the individual task briefings which detail who is doing which task in what sequence. It's as you would see a Formula One pit crew perform, with each member knowing who is doing what and in what sequence. The use of the appropriate road rail plant is essential to rapid deployment and execution of the works. The proposed solution uses a road rail lorry fitted with a high-ab crane, which is used to both offload the material and pile the foundations. The Land Rover is used for the transportation of staff and tools. The selection of transport means that the vehicles can go on track and go straight to work without the need to load or unload trailers or vans. The piling torque head is connected to the helical pile, and piling then begins with regular monitoring of alignment and positioning to ensure correct and accurate installation of the piles. Once complete, the piles are ready to receive the platform. The platform is designed in a modular fashion to suit different configurations and enables quick assembly and fitting. It's again checked for correct positioning, clearance and level. The platform is used to mount the signal plinth, post and object controller housings, and acts as a position of safety for a maintenance team working on the equipment. To install the axle counter, the plug-coupled axle counter cable is passed under the rail and the axle counter head is secured in place using the under-rail claw fitting clamp. The clamp is then tightened to the correct torque setting. This completes the mechanical installation. The installation is then verified. This includes the measurement of the height of the axle counter head in relation to the top of the rail. Tasks and installation details are recorded in the handheld IntelliTrack device. The device knows the acceptable parameters between which the measurements must fall, and if OK, the device records the test as passed. If it is not correct, the handheld device will show an error message, and if required, raise the test log for rectification. Now for the signal. The signal comes in 2 parts, the plinth and the signal pre-mounted on a post. The plinth is simply lowered onto the platform, locating with the bolts. The hinge, which is removable for security, is then fitted to the plinth. Next, the post is fitted to the hinge and the cable is fed through the plinth. The post is then raised onto the plinth, like this. Once secure on the plinth, the signal is checked for level and alignment. The pedestals are fitted onto the platform, and the object controller's housings are attached and secured in position. Now the cables can be laid into the pedestals and plugged in. Whilst the foundations are being installed, the AWS is also installed. The cable is plugged into the AWS and the cover fitted. The shield can now be fitted over the permanent magnet until the commissioning. The magnet is now ready for its verification tests, such as height checking. These results are recorded onto the IntelliTrack device. The FTN cable is secured to the ground using duckbills. These are driven into the ground, and once the tool is removed, the duckbill opens up to prevent removal. The TPWS is installed on the sleepers. This is installed after the AWS and whilst the foundations are being piled and fitted. Now that the site is cabled up and complete, the pallets are removed and all staff and plant can leave the site. The complete installation is now ready for commissioning. When all of the equipment has been successfully installed and tested, formal possession is taken so the team can move trackside in preparation for commissioning. The first step in commissioning is changeover of the fringes. Old equipment is then disconnected. Old signals are covered or removed if they obscure the new signal sighting. Old level crossing equipment is dismantled and removed from site, and new level crossing equipment is installed. The new signals are uncovered and hoods removed from the site. New automatic warning systems are unshielded to enable the permanent magnet to operate. Points are unclipped, run and corresponded. The fringes are then principal tested to ensure correct interoperation, and factors and notes are checked. The penultimate step is to conduct final correspondence, where not previously seen, to ensure that everything is properly connected and working as required. The modular scheme is then signed into work.